Alright, so now we're going to look at some further graphing techniques to help you aid with some further graphs here. Alright, so if the general graph, this is on page 36. If the general graph of a function is known, then adding or multiplying by a constant will just change where it sits on the Cartesian plane. Okay? While keeping it still general layout. So, if you have some function, okay, and you know what that function is, and you know what the general graph of that function looks like, okay? So these are all from your notes, okay? So we have C multiplied by our function. So you're multiplying your function by a constant amount. Now remember the dot means multiplying. It's also a reference to what's called the dot product, and if you are at university and you're studying mathematics or doing a mathematics course, most likely in your first year you'll be looking at vectors in part of your physics as well. Okay, and that's called the dot product. Alright, and you'll get lots about that when you get to university and doing maths. Okay, so I'm giving you the heads up now. So, as the value of C varies, the function's slope or steepness changes. Okay, this is all straight from your note. Right, we also can use y is some function of x plus a constant number. Okay, so when we're adding a constant number to our original function, what that will achieve is it will shift our graph upwards or downwards. Okay, in what's called a vertical translation. Now, if you do f of x plus c, so find x plus c for the function, right, that will result in a horizontal translation. In other words, it will move left or right depending on the value of c. Right, so let's look at some examples. Okay, so the question asks us to sketch the following y equals f of x, and then we're going to sketch the following three results from here. Okay, so we'll have a go. So E, f of x equals 2x plus 1, and we have our c as 3. Right, so when you do your graphs, they need to be a minimum third of the page, okay? All your graphs. Okay, it won't be so apparent now, but when we get later on this topic, you'll see why you need to do a minimum third of the page. Right, x, f of x.
This is my ruler. My ruler. Lol, but...
You can see a couple of people here still got their rulers that I've gifted them with. 3 people now. Kyla's upgraded her weapon. And Josh.
Keep losing all my pens, so I'm just like, keep losing one.
What sucks about being in PE room, because the tip group don't have rules.
Yeah.
Well, you have to find a straight edge somewhere.
Bye-bye.
That's the way.
Yep.
Yep, very nice. Okay, so considering your original function, we'll sketch them. We're going to sketch all three on the same axes, so we don't have to keep reproducing it. That's the other reason why we need it nice and big. Okay, so input all the information. Right, so we need to sketch the graph f of x 2x plus 1. We should all know that a straight line graph. Okay, let's find the x and y intercepts of that and do a reasonably accurate sketch. Okay, to find the intercepts, you set the opposite letter equal to 0. Okay, this is probably the most handy technique to graph, particularly with your parabolas and your linear function, finding where they cross the axes. So,
If we were doing an exam, would we be required to show that working?
as an insurance policy, yes. But if you put the incorrect numbers on the graph, Robin, and I have no evidence beforehand that you understood what you're doing, then how am I supposed to mark it right? So I'll answer your question with another question. Okay, make sure you label your intercepts, arrowheads, okay, because your function continue to what information I've got there. Alright, so the value for your constant now is 3. So we need to first work out what happens with each graph. This one goes up or down, this one goes left or right, depending on the value for C. And the first one, slope or steepness. Change it. Alright, so now we need C, lots of f of x. Okay, so I multiply 2x times 3, and that also multiplied by 3. So as well as the slope and the steepness changes, it'll shift upwards or downwards as well. Put something in down the note. Okay, so we're multiplying both 2x and 1 by 3. We'll end up with, so if we've got 3 lots of f of x, which is going to be 6x plus 3. Okay, so it'll shift it up to 3 on the y-axis. And it'll also change the steepness of the line because the number in the gradient has increased. Okay, so approximately that. So that's 3. However, the value of x will not change. Okay, so if you were considering your x-intercepts, we put y equals 0. So 6x plus 3 equals 0. 6x equals negative 3. X is negative 3 on 6, which is a half. So we have the same x-intercept and an increase in the y-intercept because of the change in gradient. Okay, so this one y equals f of x. y equals c lots of f of x. Okay, so yes, the steepness changes, but we're still intercepting the x-axis at the same point. Right, so now we need y is f of x plus c. So when you're adding or subtracting a constant, that will just shift this line in this example upwards or downwards by the constant. Okay, now because you're adding a constant, so you've got a positive constant, means your graph's going to shift upwards. If you have a negative constant, okay, your graph's going to shift downwards the number of units in that constant. Okay, so if the value for c is 3, we want to add 3 to f of x, so it becomes 2x plus 1 plus 4, plus 3, which is 4. So we're shifting this line 3 units upwards. Okay, to value 4. Can anyone now see why our graph needs to be about a third of a page? Okay. Make sure your graphs are nice and big, a minimum third of the page. Okay, if they are too small and you're trying to fit a lot of information in there, and you get to the point where I'm trying to read it but I just can't, okay, you're not going to get marks for it. Okay, and that's the same way your HSC marker will go. They'll have no emotional obligation to what you're trying to show. Okay, so we need to make sure we do the right thing from the start. Okay, and the gradient's still the same. Okay, because the gradient's still the same number. Okay, so we've got a parallel line to our first function, but the intercept on the y-axis is 4. And, of course, that'll change the intercept on the x-axis. Okay, so we shift upwards 3 units. And quickly do on the maths, 2x take away 4 equals 0. So 2x plus 4 equals 0. 2x equals negative 4. So x will equal negative 2. Okay, we need to quickly do the maths in our head to be able to translate a vertical translation of that graph. Bless you. So the idea is if you know the original graph or the original function, okay, and then you know what happens when the constant is, what effect the constant has on it, okay, you can then use this skill, okay. If you're not comfortable with this, you just go through your normal x and y intercepts and any other forms of graphing that we know. So f of x plus c. Last one, so when you're adding a constant inside the original function, so instead of just having f of x, you have f of x plus c, right, your result will be a horizontal translation, which will change both the x and y intercepts. Right, so f of x plus c is going to be 2 lots of x plus 3, so c is 3, plus 1. 2x plus 6 plus 1. 2x plus 7. So the gradient's still the same, so it's going to be parallel still to our original function, but the y-intercept now is 7. Right, so when you have when you're adding a constant, which happens to be positive, into the original function, it's going to shift in the opposite direction. Okay, because the y-intercept is 7, for it to be parallel to the original function, increasing y value up here, the actual function must be going this way, so the actual function itself is shifting over 3 units to the left. Okay, so my 7 not there, somewhere up approximately there. Okay, so this is y is f of x plus c. So last merged line, y-intercept is 7. And doing the math quickly, setting this equal to 0, this equal to 0, we're going to have negative 3.5. Okay, so the original function intercept the x-axis at negative half. When we're adding the constant, it's shift in the opposite direction with the value of that constant. Okay, so from negative half, shift 3 to the left, we get negative 3.5. So this is another technique we can use to graph. Okay, otherwise you can work out your function like so, and just do your x and y intercepts like we've done with the original one and use that information there. Any question? Alright, let's try the next one. Now we're going to look at a parabola f of x is x squared. Let's see what effects it has on the parabola. Alright, so if you've done this graph and you found it was too small, okay, that should be the indication. I should be able to put 4 lines there and I'll be able to clearly distinguish between each line. I'll be able to label all my x's and y intercepts and also label the actual line with the function it equals to. So if you found a bit like mine where it's too small, you need to increase your graph size. Right, you will have plenty of paper for your exam. Okay, use them up. Okay, if you want to put 1 graph per page, do that. Right, I'll make sure there is plenty of paper up there for you to be able to do that. Right, D, F, sorry. Right, so f of x is x squared. The value of the constant is 2. So we're going to do the same thing, c times f of x plus c, and f of, in brackets, x plus c. And see what changes that has to our parabola. Alright, so you all should know what the original function looks like. You should all know where it lies on your number plane. Okay, you should all be able to sketch it. Okay, so before your exams you need a bit of practice on your parabola drawings. Okay, I'll give you a bit of grace during your marking because you're only just learning them and we haven't done graphing in any great detail and you won't have a lot of practice before your exam, so I will give you a bit of grace before your exam. Okay, but after that we'll need to be a bit more strict on how our graphs look like. Okay, now you can do your graphs in pencil. Okay, so you can take a pencil in there with you, draw a light graph of the curve. When you're happy with it, you go over it in pen. Okay, the reason why you need to go over it with pen is because in your HSC exam, they will photocopy your answers. Okay? Some pens, sometimes when they get photocopied in some form of pencils, when they scan it and photocopy it, the actual graph won't show up. Okay? Because you've done it in pencil. Alright? So, my advice to you is to have a very light pencil. And a rubber. Okay? You'll do these graphs with a pencil. Not happy? It's great. It's okay, sorry, not great. If you're not happy, you rub it out and do it again. Okay, and then go over it in pen when you're happy with it. And it's a gift. Okay, you need to get your rubbers. Alright, it's probably a good thing to have. Go over with pencil first and then go over it with a pen. Alright, that's your original function. Alright, so what happens when we have c times this f of x? So, c lots of f of x. So we have 2 times x squared. So we have 2x squared. Okay, so when you're multiplying a function by a constant, the slope or the steepness of the graph changes. Okay, so what that will mean is that the curve will be a lot more steeper. Okay, so it'll go up a lot quicker than it did with the original parabola. Did lose something? Okay, so just like your line, it made the gradient increase the value of the gradient. Similar concept here. Alright, so f of x plus your constant. So the constant value is 2, given to you in the question. Okay, so when you're adding a constant at the end of a function, the graph will translate upward or downward the value of the constant. Alright, so we have x squared plus 2. That means the original graph, f of x squared, shift up 2 from its current position. Okay, so that means the y-intercept is at 2. And it's the same shape as the original function, up 2. You can also tell I'm going to be able to practice as well. This is f of x plus c. So when you're adding a constant to a function, that shift up or downward depending on the value. So we have a positive 2, means it goes up by 2. If we have a negative 2, okay, so the negative number goes in the negative direction. Okay, and then you also have to find the corresponding x-intercept, because now you have x-intercept when you go down by 2. We've all seen how to do the x-intercepts from the previous lesson. Alright, f of x plus c. So when you have a constant incorporated into the original function, not just adding it at the end of a function, that will translate in a horizontal movement. Alright, so we have x plus 2 all squared. Remember the original function with f of x is x squared, so f of x plus 2 is x plus 2 all squared. Okay, you can go ahead and solve for, expand that out, solve to 0, but you're just going to end up factorising again, back to that form. Right, so, because you've got a positive 2 incorporated in the function, right, you translate horizontally in the opposite direction. Okay, so you've got a positive 2, we translate in the negative direction. That means we go this way 2 units, and it will turn on the point where x equals negative 2. What is the y-intercept? Y-intercept, where x equals 0. 0 plus 2 all squared is 2 squared, which is 4. Okay, we can quickly do the maths there. Okay, so that's just a further technique. I don't necessarily expect you to remember it. However, for you two, you've got a graphing unit coming up, and you also have a dedicated graphs topic in Extension 2. It'll be handy to know some of these things. Alright? It will be very handy to know some of these things, alright? Not necessarily for your mathematics or extensions. But. Right. Any questions? Does everyone understand what I'm trying to show you? Okay, use it if you want. Otherwise, you know the skills to be able to graph your linear functions and your parabolas, alright, by using your intercepts. Right, so that covers exercise 5.5. Right, we'll make a next start of the next section. 5.5, absolute value. Function. Okay, so way back in term 1, we looked at absolute values, what the definition is. So now we're going to incorporate those, what the graphs look like. So, the graph of absolute value functions are V-shaped. Okay, so we take the typical one, so take f of x is the absolute value of x. Okay, any part of the function below the x-axis is reflected about the x-axis, so that the graph only had positives or zeros as its y values. Alright, what I mean by that, so I'm going to do a rough sketch now, because I'm not asking you to sketch. Right, so if I have f of x, equals x. Okay, what's the gradient of that line? 1. The y-intercept is 0. Okay, so we've got that diagonal line right between the centres of the first and third quadrant. Okay, so that will do, y equals x there. Okay, when you take the absolute value, right, as we have seen in the definition, we take the value, the absolute value of a number, it'll return the positive equivalent. Okay, so if you take the absolute value of a positive number, it's the same number. Okay, when you take the absolute value of a negative number, it's its positive equivalent. Okay, graphically, anything that is below the x-axis, so you have a negative y value, you reflect this part of the graph upwards about the line, the horizontal line here, upwards, so that all your values of y are either positive or 0. Okay? So, y is the absolute value of x. Okay, without, yeah, probably haven't got it. Let's do it properly. Alright, so it's just a quick sketch of what that looks like. Alright. Okay, so what was down here, it gets reflected about that horizontal line, like you almost fold it in half, and the print that it will leave is what's up the top there. Okay, because that matches the definition of absolute value that will return either 0 or a positive value for y. Alright, examples, graph. Following absolute values including all intercepts, state its domain range. Right. A. So f of x is the absolute value of x. So I'm asking you to graph, so now you need to use your rulers. Okay, so the question doesn't ask you to graph, you can do a quick freehand. These won't need to be a third of a page, so if you want to make them a bit smaller, that is fine with me for now. Well, we're learning the concept, but when you're doing your questions, you'll need to make them bigger, so you can have it. So?
Isn't that what we just did?
So?
Isn't that basically what we just did?
Yes, so I've just done a freehand here, and now we're doing it properly.
I did it properly.
Alright, so the absolute value graphs are V-shaped. But make sure what you have on either side of the y-axis is symmetrical as well. Okay, because there is symmetry involved. Okay, mine's not that great. Okay, including all intercepts. The only time you don't need to show the intercepts is when it's at the origin. Okay, and you show clearly it's at the origin. Okay, now we need to state the domain range. Okay, so what is the domain of that function? So the question you should be asking yourself is there any restrictions on the x values I can have for that function? Nope, so it must be all real. Now, some people in their quiz have been writing the extra line in above it saying all real values of r can exist. Okay, that's not necessary. If you need to do it, I'll just showing you word what that means, but mathematically we're going to make our time much quicker by using symbols to communicate our understanding rather than writing sentence. Okay, so that is all I require. Okay, what about the range? Okay, so we cannot have a negative y value for your absolute function. Okay, so y is an element of all the possible numbers. Okay, the semicolons mean the conditions such that. Okay, so y has to be greater than or equal to 0. What's the alternate way you can say that last bit?
Y not less than 0.
Okay, if you want, you can say, or y cannot be less than 0. Okay, that's the alternate way you can say it. Either way, I'll give you your marks. Alright. F of x is the absolute value of x take away 3. So this goes back to your work we've just done when we're adding or subtracting a constant within the function. Alright, the same principles apply here. It shifts horizontally, but does it go left or does it go right? It will go to the right. Right, if you don't understand that, x-intercepts, do your intercepts work. So, 0 is the absolute value of x take away 3. Okay, there's only one thing we can do to x to make it 0. So x take away 3 equals 0. Alright, so when you're subtracting a constant, it shifts in the opposite direction when you're including that within the function. Alright, so your intercepts works also handy for your absolute value graphs, okay, because from those intercepts we can do the graphs. So f of x is the absolute value of 0, take away 3, which is the absolute value of negative 3, and when we take the absolute value of a negative number, it returns a positive number. Alright, we'll get this done quickly. Okay, so if you understood the work that I started with this lesson, okay, we would not necessarily need to go through that work. If you're not quite comfortable or you would just really prefer just using your skills already, that is also fine. So, it crosses the, touches the x-axis at 3, it won't cross it, and the y-axis also at 3. Okay, so you need to include all your intercepts when they're not at the origin. And before we leave, let's do the domain and range. So what's the domain? Are there any restrictions on the x values? No. No restrictions at all? So x is an element of your real number system. Any restrictions on the range? Okay, so same as the original function, even though we've shifted horizontally. Okay, we'll finish that up on Thursday and we'll move on to hyperbolas and circles as well. You can keep it. That's right.